So in the previous video, we talked about the sampling distribution of the sample proportion p hat. We looked at it through its formula. We looked at applying the 6895 99.7 rule to it. But we got to the point where we want to be able to find probabilities no matter what my value is for p hat. So in order to do that, we're going to need a z calculation, just like we had back in Module 1. So let's talk first about what our z looked like in Module 1. So our z formula was our y minus our mu divided by our standard deviation. And remember, so mu was our mean, sigma was our standard deviation, and y was just the observation that we were interested in. And remember, z measured how many standard deviations the observation was from the mean, and also told us in which direction based upon if it was a negative value or a positive value. So I want to follow this similar idea because keep in mind, in our videos we were working with before, we still have a mean and a standard deviation. So what is that going to look like for me now? Well, I'm still going to have something minus something divided by something. So the process of my z will look the same. But now my mean that I have, remember, so our mean of p hat is whatever p is. So where I had mu before, I'm going to plug in p. Also looking at my standard deviation, our standard deviation of p hat is this square root number that we had before. So it's going to replace our sigma that we have. Now let's talk about y. Y was our observation that we were interested in. Basically what we got from our person that we had sampled or been working with. Well, we're no longer just sampling one thing, and we're more specifically than recording something that's categorical. So instead of y, we're just going to have our p hat. So our p hat is going to be, this time, our observation that we get. Because it's what we get from our sample. So let's suppose I got 33% black beads. That would be my p hat. Remember, the p still here is our mean. And this whole square root thing here on the bottom is our standard deviation. So we're following the same process as we did here. So let's see if this makes sense as we actually answer our question we ended the last video with. So I'm going to start by drawing my same picture that we had. All right, we went up to 3 standard deviations away. And then we had done our calculations. So this is the exact same picture we ended the last video with. And then we took that 33%, so that it fell about right here, because it's 0.33 in decimal form. The greater than tells me to shade to the right. Okay, so same picture. Our thing that's new here is we're actually going to calculate our z. And this is our formula. So our p hat is our sample proportion. That's this 33%, or in decimal form, the 0.33. Our p that we had was 40%, or it's the number that's in the center of our graph. And finally, our standard deviation was how big this increment was. It was a calculation we did last time up here using our N and P to get this 0.049 number. So that's what our number is going to actually look like as we calculate our Z, which should give us a Z of negative 1.43. Now, looking at our picture, that should make sense. The fact that Z is negative is just telling me that my number fell below or to the left of our mean, which it does. And then the magnitude, or how big in a sense the number is, tells us where we fell, right? This is 1 standard deviation below the mean, 2 standard deviations below the mean. So I can tell this should be between 1 and 2, but as a negative number since it's to the left. So this number is between our negative 1 and negative 2 because it's between 1 and 2 standard deviations below the mean. Now once we have our z-score, we can use all the rules that we learned in our Module 1 with the normal distribution when we're using our table. So let's bring up that table as a reminder. So this was our normal table. And remember, it's telling us how much is to the left of a given z-score. So our z-score is between our row and our column. The first side is all the negative values, and the other side is all our positive values. So when we're looking here, we are actually shaded to the right, but our table is shaded to the left. So we're going to have to use that as we go a little bit further. But let's first just take our negative 1.43 to our table. So the negative 1.4 tells us which row to go to in the table. And our second decimal point, our 3, tells us which column to go to in the table. So I'm going to first make sure I'm on the negative page. And I'm looking for negative 1.4, which is there. And then I want that 3 column and find out where those match up. Give me this 0.0764. So that's what I get when I went to the table. But again, remember that table is shaded to the left. So what that would mean on my picture is this 0.0764 is this piece. It's to what's the left of that number. That's not what I want, but it can help me find the right number. So if this is about 7.64%, this is the rest of it. Right, so how can I actually, again, find my probability? Well, if I just take 1 minus that number we got in the table, that's going to give me everything else, since I have to add up to 100%. So then this piece that I actually want is the 0.9236. So this 0.9236 will be our answer. But of course, finally, we want to interpret our number. So when 40% of all beads are black, which that part is really using that we were told, and we're using that P is 0.4. There is a 92.36% chance that at least 33% of the 100 beads sampled are black. So is it very likely to happen that you're going to get at least 33% black? Yep, there's a 92.36% chance that that's going to happen. Right, so this was just a first example to understand how to use the table to help us calculate our probability. In the next video, we're going to do a full example with context, go through sampling distribution, normal curve rule, and doing probabilities all at the same time. It's very good practice video.